Alrighty, welcome everyone to day 15 of Advent to Code. Let's get right into our problem here. Let's do this. You feel the ground rumble again as the distress signal leads you to a large network of subterranean tunnels. You don't have time to search them all, but you do have time, but you don't need to. The pack contains a set of deployable sensors that you imagine originally built to locate lost elves. The sensors aren't very powerful, but that's okay. Your handheld device indicates that you're close enough to the source of the distress signal to use them. Pull an emergency sensor out of your pack, hit the brake button on the top, and the sensors zoom off down the tunnels. Once the sensor finds a spot it thinks it will give the good reading, it attaches itself to a hard surface and begins monitoring for the nearest signal source beacon. Sensors and beacons always exist as at integer coordinates. Each sensor knows its position and can determine the position of a beacon precisely. However, the sensors can only lock onto the one beacon closest to the sensor, as measured by the Manhattan distance. Okay. Never a tie where two beacons the same distance as the sensor. Gotcha. It doesn't take long for a sensor to report back their positions and the closest beacon to puzzle input. For example, so this considers the sensors at 218. The closest beacon to is at okay. This isn't necessarily a comprehensive map of all the beacons in the area, though, because each sensor only identifies its closest beacon. If a sensor detects a beacon, you know that there are no other beacons that close or closer to that sensor that could be okay. Consider the sensor there. Okay, the sensor's closest beacon is at that, so you know that there are no beacons close from that. None of the detected beacons seem to be producing a distress signal, so you need to work out where the distress beacon is by working out where it isn't. For now, keep things simple by counting the positions where a beacon cannot possibly be along just a single row. So suppose you have an arrangement of beacons and sensors like the example above, and just in the row where y equals 10, this one. You'd like to count the number of positions a beacon cannot possibly exist. The coverage from all the sensors near that row look like this. In this example, in the row, there are 26 positions where a beacon cannot be present. Consult the report from the sensors you have displayed in the row where y equals that. How many positions cannot contain a beacon? Oh boy. These are some big numbers, and I can already tell you that it's gonna be a question of they're getting these large numbers because there's a slow way to do it and a hack way to do it, and there's a efficient way to do it. We need to find the efficient way to do it. Right. So a sensor is a beacon by it, so we need to figure out none of the detected beacons seem to be pertinent. So a comprehensive map, all the beacons there. Because each sensor only identifies its closest beacon. If a sensor detects a beacon, you know that there are no other beacons that close or close to that sensor. There gets to be beacons that just don't happen to not be the closest beacon to a sensor. Consider the sensor. Okay, so we just need to figure out. Right. So we're only considering this. So we can shorthand this. By taking the XY position, finding the closest at, and then calculating the Manhattan distance to that, we can check for just row whatever number it gives us. We don't need to map the entire thing out. So let me take this. I'm going to need this here. So for string s in inputs, we're going to need to do s equals what is the best way to break this up? Honestly, it might be to replace each individual bit, just get this, the comma, and this, and a space, and then split it. Or we can just do string sx is going to be equal to s dot substring 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 to s dot index of a comma after 12. And then sy will be likely, so it's, okay, how about this? Int C1, let's do this. Okay, so there's C1, and so this is gonna be C1, 1, 2, 3, 4. And we're gonna go to a colon. Technically, I don't need this. I don't need this at all. Okay, we're gonna cheat the system. I don't actually need to care about this because the first comma doesn't have to be for 12. We can do that for the other one. This one, on the other hand, bx, we will need C. We will need this, okay. And I will need this because this one's going to be a substring of colon plus 1. Wait, why am I counting this again? I did this the other day too. Plus 25. And then it's going to go and find the next comma after that. And then from this, plus I'm going to guess 4 again. This is going to be by. Just go to the end of the string. And let's just go ahead and just integer parse these. Make life a little easier. Okay, so now we have parsed out the sense of the beacon. We can just get the Manhattan distance to this. The Manhattan distance is the straight up X and Y. It's there, or it's the. Make sure I got this right. I believe it's just the X and Y. There's no, yeah. There's not like a, there's no Pythagorean theorem. Yeah, so X distance plus the Y distance. So, 1, 2, 3, 4, 5, 6. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, okay. Just want to make sure. I'm going to verify I was right at the Manhattan distance there. So now we just need to find the Manhattan distance to this. So it's going to be int dist is going to be equal to math.absolute of sx minus bx plus math.absolute of sy minus by. Sorry about the train that's about to go by. So we have the distance here. So now, knowing this distance, we can now map all of the positions on the this y that it can't be at. Is there... Sorry. So we see a couple of positions where it can't be. So this is where we get into points. So now we can go make our list. We don't need a list of points. We can just do a list of ints. Integer. This is going to be invalid points equals new array list. I messed that up somehow. And so from this, so what we're going to do is we're going to have to do is I need int part 1y just to make my life easier. So part 1y is that, so the remaining is part 1y minus distance. Oh, sorry. That doesn't matter. Distance minus part 1y. It doesn't matter because it's actually no. It does matter. Yeah. So if remaining is less than or equal to 0, actually if it's less than 0 is all I care about. Continue. Otherwise, if there is some remaining, what we need to do now is calculate all of the positions that it can be. And this is easy because we always add, this can be a set, by the way, so it makes our life easier. Having a set makes our life easier because we don't have to worry about the duplicates. This will do it for us. Always want to do invalid points, add the sensor x, and then for int I equals 0, right diagonals, we can start 1, while I is less than remaining, I plus plus, and we will go ahead and add both positions, so go ahead sx plus I and sx minus I. And that should be all we need to then calculate this, honestly. Is there anything I'm missing? I can't think of anything I'm missing. I get 0 though, which is a problem. Let's start with the example input because that's gonna be a little bit easier. And this is gonna be looking at 10. Let me just do this. What does this give us? 1. Huh. I should go on the next line. Remaining is -3, -9. Distance is 1. Distance is 3. Hold on, let me redo this. X is 2. There's no sensor at X of, oh, here. So its remaining is -3. 1, 2, 3, 4, 1, 2, 3. So that's 7. That's right. Which means, yeah, it can't. Distance is 7. So that is right. Okay, so why does nothing see line 10? Distance of 1. 9, 16. Sensor at x equals 9. Oh, that is right. Okay. So this is right. 13, 2. Okay. Which ones can? I wish it would tell me which ones could see line 10. The one example is sensor at 218. So let's find 218. 20. There's a 20. Oh. Oh, sensor 87. Ah, that's one I just passed. Haha. Welcome to debugging. Debugging is fun, isn't it? So once 8, 7. 8, 7. Distance you can see is 9. I see. It's distance. But we need to add in the sensor X. Or it's not, it's distance. Distance you can see from the X. That could be positive or negative. This comes down to no, so this is right. So it's the distance you can see. So 10. So if you can see 10, remaining is wrong. What do I want? I need to know if it's less, greater than, or less than. So I need to know which direction I'm going. Because if it's at 8, it needs to go up. How does this work? I'm so confused. Why am I so confused on this? This is such like a simple little math bit. I need to determine if sensor X is greater than the sensor X is greater than party 1, means it's above it. Which means remaining becomes distance. Dude, why can't I think of how this works? Sensor's here, line 10. It can see 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3 gets to 10. So it's 10 minus 7. Right, so otherwise the remaining is gonna be the SX minus part 1Y. That's how much it has to cover. And then it's distance minus that. If it's greater than, we have to do nope, this is backwards. This goes here. This goes here. Oh my goodness, that was way too difficult. This can be simplified, but I'm gonna leave it. That was, I don't know, that was way too difficult. All right, 14, making progress. Okay, 8, 7. Let me go to it. 8, 7, remaining 7, good. So at line 10 should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This one should add 12. 8s are invalid points, so we should be at 20 after this. And we're at 13, which doesn't seem right. So I want 8, 7. What's going on here? We already added 8. 7, 8, 9. We've already added it. What am I missing? What am I missing? So that's at 8. We've already added it, and now we're going up plus or minus 7. Two, 3, 4, 5, 6. Okay, so it's just not reaching. Something's missing. It's only getting 14. What am I missing that's only getting 14? $11, $12, $13, $14, $15, $16, $17, $18, $19, $20, $21, $22. Okay, so we do need to exclude beacons, which is gonna be fun. If beacon y equals part 1y, beacon 6 plus plus. Okay, that'll fix that. So what am I missing for this? Is it the other? So we have this one working. If sx is greater than part 1y, so if the sensor x is up here, so 15 minus 10, that gives us 5. 1, 2, 3, 4, 5, and then we go out left and right. I don't see what I'm missing. I don't see what I'm missing. Technically, I don't actually. I can just do 0. That does work. Is it less than or equal to remaining? Nope, so I only get 13. Huh. I get 0 to 15, which is only to here. One of these sensors, I'm going to assume sensor at y is 14 isn't working. So let's find that sensor and continue our debug. So SY14 is what I'm looking for. 12, 14, is that it? Nope, I want 2014. Why is it? Oh, it must be on the 1420 or 2014 is looking. There we go. I get remaining of -2. Sensor X is at 20 because I'm using X, not Y. I'm dumb. People, I'm sure, were just seeing it right in front of their faces, and they could use an X, not Y. Hey, 24. That's off by 2, I think, right? Closer. Closer. So I have a -2 to 24. -2, 24. I'm missing some middle ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 17, 18, 19, 20, 21, 22. No, it's 26. It's excluding 3 beacons. Hello. Did I check X's? No. $24, 25, 26, 27 minus that 1. So I'm right. For some reason, though, my beacons to exclude is 3. Why is my beacons to exclude 3? What beacons am I excluding randomly? I'm excluding the closest beacon. Okay, so this needs to be a set of points. Add new point. Beacon Y, beacon X. I see. Try this again. Please give me 26. Thank you. This problem was a lot more painful than it should have been. Careless mistakes, careless mistakes. And I'm wrong. Huh. Got the example right. But I got my problem wrong. Yeah, 26. Huh. Oh, you know why I got wrong? Because I didn't change my Y. That would be why. It's gonna give me a time limit? Yep. Alright, please, I just... Can I, like, ever solve one of these problems and not, like, have some just some, you know, dumb mistake? Hey, part 2. Handheld device indicates that the stress signal is coming from a beacon nearby. The stress beacon is not detected by any sensor, but the stress beacon must have an X and Y coordinates, each no lower than 0, no larger than 4. Whatever. So this is stress signal, beacon signal. You need to determine its tuning frequency, which can be found by multiplying its X coordinate by, okay. The search space is smaller, okay. Can be at most 20. Okay. And the only position for the distress beacon. So there's only one spot the beacon can be, and that's 1411 right there. So that's too big of a list. That's 4 million times 4 million. That's way too big. That's 4 million by 4 million. So, how do we go about this? Okay, I have another idea here. It does involve going line by line, but it involves every line going through all of these. I do need an int x is going to be equal to 0. And I just need to know, I need to make a method here of if it contains, or not that, private, skip over line, give it the input line, the int y, and the int x. So let's do xy. So given the current xy, skip over, so it's going to go do this logic here. First thing to do this. This gets the distance it can reach. And then we need the remaining, where line end, or line defined, is y. And then, given remaining, we need to do a check here if x is greater than, or x is greater than or equal to sx minus remaining, and x is less than or equal to il dot sx plus remaining. If it's within this, we can return this. Otherwise, we're going to return x. What this is doing is basically, the goal of this is we're going line by line here. We're starting at 0, and then we're looping over all of these, all of the scanners, and we're saying, all right, take me to the end of your line. So say we're right here. It's saying, okay, find me the scanner. So it finds the scanner here. We're within this line. It says, okay, now just skip over all these and take me to here, is what we're saying. So actually this should be +1. But if we get x back, that means it hasn't skipped over anything. X equals skip over this, give it list item, whoops, give it il, give it x, give it I, and then do a check here. Actually, this will do int new x. If x equals new x, we have our solution. We're done. In theory, we're done here, but I don't think that's actually going to work. And break. Well, either way, we're breaking. This is our il. Otherwise, we're doing is x equals new x, break. Why is this redundant? Ow. And this needs to be a while x is less than max. Whoops, let's go up here. That's why it's probably complaining. Okay, so while it's less than max, less than equal to, by the way. Let's see what we get here. Zero, zero. Good to know. Good to know it fails right away. Fails right away. Really? None of these catch it? One of these has to catch it. The S. Oh wait, no, not SX. No, yeah, SX is right. What's remaining minus remaining right? Remaining is, yeah, the distance that, yeah, so that's for that line. Run this one. What do we get here? Is it also give us 0, 0? Okay, so it's still saying 0, 0. That's not right. Because there should be this sensor should be covering 0, 0. Yeah, this one right here. What is going on? Why don't you see 0, 0? That's this distance from the sensor. So if X is greater than... Is this working? No. Which one do I care about? I care about at 2, 0, I think, right? What? Oh, no. I see what's going on. This is the wrong spot. This is in the wrong spot. This is our new X. Gotcha. I need this check here. If that's where we break. This is where we go ahead. I see. And new X equals X, new X is that. Does not equal break. We're done looking for this. So now we need to check is if new X equals X still. This is where we want the system.out.println. Sorry about that. This is where we want a new line here. And this is where we want to break from this and go about it. Does this work? Okay, I should have been a little bit better about this. I should do should have done that. Oh, I, not Y. So we're gonna get one spot and okay. What if I just do I equals max plus 1? That way it stops this whole fun time. We get 27, 0. Well, it'd be helpful if I limited it to the correct max. It worked. Oh. Oh my goodness. Do not tell me I just solved this. Lap. What was the math on this? Holy crap. X times max plus Y. Dude, I swear. I, not Y. No freaking way. Nope. Unless I put the wrong math in here. Oh, I copied the wrong value. Dummy. But that's the wrong math. What is it? X coordinate by... Oh, well, it's because it's the wrong... by the way. Okay, so that's right. Okay, so put this back to max. Put this back to whatever it was there. Undo that. I copied the wrong value over. That'd be helpful if I copied the right value. 5 more seconds. Just be right. Please be right. I swear. Oh, it's still wrong. Your answer is too low. My answer's too low? Really? Why am I too low? I, not why. Keep doing that. I only get one coordinate. That times that plus that. That's not the value I copied, right? Am I just doing this math wrong? It's a long, isn't it? It's a long. It's a long. We're done. We're done. Oh my god, we're done. I'll probably be cutting a lot of that out because I spent like 45 minutes, almost an hour probably. Not quite, probably like 45 minutes on a solution that was correct, but just incredibly slow. Not what I wanted. And by some stroke of, like, I don't know, an epiphany, I figured this out. I don't know how. Holy. I seriously do not know how I came to that. I should still set I equal to max plus 1 though, just to end it. That is beyond. I do not know how fast is it. It gets in a second. Honestly, I'm impressed with myself. I got it in a second. Wow. Let me. I don't. It's late. I don't want to clean up too much of this, but I might as well clean up this logic here. Get gear remaining. I'm gonna call gear remaining there. Okay. Don't need that. This can be that. Oh, it's line defined, right? Condense the logic down just a bit. Because then I can return. I can actually use logic even a little better. And condense it down even further. I could make this one line, but I don't really want to do that. That seems excessive. So now this can all come out of here. And for a part 1. What was my line defined? What was my line defined? My line defined was this. Okay, I think that is everything. As good as I'll get it, I guess. I don't know. Wow, that's alright. So solving today's problem. I won't go over the parsing. The parsing is pretty easy. Just parsing the input, that's pretty basic. Part 1 is not too bad either. It's just making it a little more efficient than needed. Basically, you go on your line defined. You then go over all of the inputs that are given, so all of these. And then at that line, you determine what each sensor can see of that line, which is what remaining does. So we from the sensor, we see how many spaces that sensor can see in that line, or I guess not spaces, but the radius it has still left in that line. And then using that, we then add all these invalid points. So basically, example, this one, so line 10. So this can see 9, I think it was 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can see its Manhattan distance is 9. So if we go to line 10, 1, 2, 3, it takes to get there. So we can see 6 spaces. So it says this still has 6 distance left, the Manhattan distance left. So we add this one, and then we do 1, 2, 3, 4, 5, 6. Add these 6 to the right, add these 6 to the left, add them all to our array we have here of invalid points, and then do it for all the scanners. And that's all part 1 is. We remove the beacons because the beacons don't count in this. That's why that's there. Part 2. Part 2 is a little harder. Explaining this. Basically, we go line by line, and then for each line, we start at x equals 0. So start here, and we find the sensor that can see it. So we find the first sensor that we come across that can see it. In this case, is this sensor. This sensor has, I don't know what the range is. Let's just say the sensor has a range of 5 as Manhattan distance. What we do is we go, okay, this sensor on line 0 has a Manhattan distance of 5. If it was on line 1, it'd be a Manhattan distance left of 4. The same thing that came with this line. So using that logic, so in this case 0, 0, this sensor can see as a Manhattan distance of 5. We find where that ends on this line, which would be like right here. Well, it'd be right here. Add 1 to it, which is right here, and then set our x coordinate on this line to be here. Repeat the process. Find the sensor, I can see it, find where it goes to on that line, move it to there, and then when we get to a line where we get to an x coordinate that no scanner can see, we found our answer. And that's all that matters. So it's that moving in chunks is what makes this be fast enough to where we could go through all 4 million lines possible. And that's it. It took a while, but we got there. Anyways, that is day 15. Hope you guys enjoyed. See you guys tomorrow for day 16. Peace out.